Thank you, everyone. My name is Rafinetti, the CEO of Hyphen. Very pleased to be talking about this project in Namibia. We spent so much time talking about this project in other parts of the world. So, very briefly, Robin's touched a lot on why green hydrogen, some of those key questions. For us, the world has changed fundamentally. Between the 23rd and the 24th of February, the world has changed fundamentally. The world has committed to net zero. 90% of the countries on the globe have committed to net zero. That means that you've reached that tipping point where the world has decided this is something that needs to be done. Combined with that, on the 24th of February, with the invasion of Ukraine, you have an incredible change in the energy market in Europe in particular, but globally. It's hitting the US. That has having a fundamental impact upon the economics for green hydrogen. And then another point that Robin touched on was security of supply. Security of supply is critical. We always spoke about this when we were awarded this project, preferred bidder status back at COP26. We always spoke about security of supply. If you're going to remake energy systems and dependencies, it might be useful not to create something the world currently finds itself in. So what that has done is this has dragged forward the point of economic viability of green hydrogen at scale. Because today, based on green ammonia pricing in Europe, it is 4 times the price that it was pre. What does it actually mean? It's a huge amount of analysis on one area. You obviously start with the resource. You have to go to the place with the best sun and the wind in the world. But to Robin's point around government mobilizing around a common vision, I don't think there's another country in the world that's doing what Namibia is doing. At a coordinated government level, at a senior level within government, where this is such a high national priority. And it is only with absolute drive and conviction can difficult, complicated, incredibly complicated projects like this nature be realized. And we think, certainly on the African continent, we think Namibia is untouched in terms of its competitive advantage, and that competitive advantage is its natural resource, plus all the other things that make countries successful. The rule of law, the democratic principles that underpin government, the strong budgetary, fiscal, all the boring things that people take for granted that are so incredibly important if you're going to win the support to mobilize capital to invest into Namibia on the scale that's required. Again, what does this mean in terms of the supply chain? The world has to build an enormous amount of capacity across the entire supply chain in order to make decarbonization work. Now, what does that mean practically for Namibia versus, I picked a proxy country in Germany. If you look at the wind and the solar in Namibia, if you had to replicate the same output of hydrogen in Germany, you'd need to build twice as many wind turbines. So for every wind turbine in Namibia, you've got to put up 2 in Germany. That means you need twice the amount of equipment, twice the amount of capacity in factories, twice the amount of land. So the impact on land becomes enormous. On solar, it's even greater. Namibia has a 3 times advantage over Germany. Again, that goes all the way through the supply chain. So for us, it's very, very simple. If you go down to basic fundamentals, if you have a constrained supply chain, you need to get as much hydrogen into the economy as you possibly can in order to drive decarbonization. It makes sense to go to the place in the world where you need to deploy the least amount of equipment because you can do it the fastest. It was important for me to start with what it means for what the decarbonization journey looks like, because we need to put this all into context. This then becomes the two land parcels that have been awarded by government through the first tender process. So if we look at the area, it's around 4,000 odd square kilometers. The entire Sakahebe area is somewhere in the order of 26,000 square kilometers. So a relatively small proportion of that land. Hugely environmentally sensitive, as I'll touch on in a little while. What I'd like to do now is, let's just go back. What I'd like to do now is just show you a short video of the project. It'll start with a fly-through starting at that point E in the middle of that graphic, so at the electrolyzer. You'll see wind turbines, solar panels, an electrolyzer with a central manufacturing facility for the manufacture of hydrogen, and then you'll see pipelines bringing water in, taking hydrogen back out, and electricity to the port, and then a port precinct for the production of green, where the green ammonia where the hydrogen will then be combined with nitrogen to manufacture green ammonia for export. So this is an actual rendering of the project site in the slide ahead. So you can see the distance between wind turbines is very, very great. It's around 1 to 1.5 kilometers of distance between them. The solar panel arrays are in the foreground. This is now looking on the right-hand side of that screen. You've got battery packs that then support the production of green hydrogen in these warehouses. You have water coming in, and then hydrogen pipelines taking the hydrogen back out into the connecting corridor to take the hydrogen back to the port. And the reason why we move hydrogen as opposed to move electrons is because it's the most efficient. It's the most efficient economically, it's the most efficient environmentally, because you can move large amounts of energy in a very, very small piece of infrastructure. As an example, to move this amount of energy in a electricity form as opposed to in a pipeline, we need 4 times 400 kV transmission lines. That's 200 meters wide of infrastructure running down the length of the park, as opposed to moving it in one very discrete pipeline. This is then the chemical production facility, and now this is the export facility into the vessels. We're looking at multiple technical solutions for the export of the product. This is one of the technical solutions we're looking at. It's called the multi-boom mooring system, which is a rapidly deployable system, has a small environmental impact because you don't need to build breakwaters. Ultimately, to export the scale of hydrogen that is proposed for the production potential of this region, it would require the building out of additional infrastructure. So what have we been doing since COP26 when it was announced? I think the anniversary of the launch of the RFP was on the 3rd of August, so it's almost a year to the day since we started throwing ourselves wholeheartedly at this project. Formally, through the process. Before that, we've been working on it for at least another 6 months before that, very, very hard. The reason why the environmental is first is because that's the most important. Out of everything we do in the environment is the most important. We are here with these projects in order to drive decarbonisation. What we cannot be doing is harming the environment in the process. We've done an enormous amount of work to plan on how one could implement a project of this nature in this very, very sensitive environment in a way that is going to be ultimately sustainable. We've been then working very closely with government on the SCDI master plan. That is, we need to build infrastructure that's not going to only enable the first project, but is going to enable an industry. How do we do that in a way that master plan is aligned with government's long-term aspirational goals? Legal and regulatory, there's been a lot of discussion about that today. There's been a huge amount of work. Lawyers will get rich from this process, as they always do. It is very, very complex to build the architecture for a new industry, and this is something that government has taken the lead on. And with a blank piece of paper, before incentives and structures are put in place that do not drive the long-term behavior that you want as a country, this is a key objective of government, to make sure that with a blank piece of paper, we make as few mistakes as possible. We will always get things wrong. It's impossible to build a new industry and something of this scale in Namibia without making mistakes, but we really, really need to minimize any mistakes we could possibly make. Because we're still in the pre-feasibility phase, we have been focusing on pre-feed engineering studies, looking at how do we minimize the environmental footprint, how do we maximize the potential for Namibia through the overscaling of common use infrastructure, how do we design that common use infrastructure in a way that there's a de-risking of the project for subsequent projects that come along. And then last but not least, an incredibly important work stream is socio-economic development. We've hired a person to lead this specifically, and we actually now have 2 people in the socio-economic team. So as I think we're now up to 6 employees in Hyphen, all Namibians, all based in Namibia. Socio-economic development is the largest team within that, we've got 2 people. It is so critically important. Without winning the hearts and minds of Namibians and bringing everybody within Namibia along on that journey, we simply aren't going to be successful. And this is what it really means to Namibia, which is trying to answer the question that was set for us. Hyphen is a stepping stone. It's the first stepping stone in this journey for Namibia. We think that conceivably, Namibia could get to 15 million tons of hydrogen production a year. That is 3% of what the world needs. Again, it's a drop in the ocean, but it's a meaningful contribution. That is 50 Hyphen-sized projects. The measure of success for us as Hyphen is that we need to work with government that our first step, the first foundation stone for this industry that is laid, achieves that long-term objective. Because ultimately, that is what the world needs. As humanity, to be successful, we need to drive decarbonization. It raises very, very difficult questions, some of which have been posed today, about how do we do that in the most sustainable way. But if we don't as humanity, the future is going to look pretty bleak. Now, in order to achieve that, it requires a mobilization of capital into a country that's never been seen in the history of the African continent, let alone in some developed areas. It is simply an enormous amount of capital. Just the first project at 1/50th of the potential of Namibia is roughly equivalent to the GDP of the country. And with equipment prices and the war in Ukraine, pricing has actually gone up. So is the scale of our project. So we're over $10 billion now in terms of scale. As succinctly as possible. Thank you.